name is Anna Solomon, and I am the tutor behind Flamingo Tutoring. Today, we're going to talk about the vocabulary behind the math in the SAT and ACT. So I'm going to go ahead and share my screen. You can find this worksheet on my website, and I recommend following along and filling it in. All right, so first, let's do some measures of central tendency. Measures of central tendency start with mean. Mean is the average, and you find the average by finding the sum of all of the numbers and putting them over the number of numbers. All right, so, and we'll just do one of those. All right, and then the median is the middle number when the numbers are in order. That's the big trick. Most students can find, you can find the middle number, but you need to make sure they are in order from smallest to largest. All right, the SAT particularly loves to put them out of order. Then we have mode. Mode is the number that appears most often. All right. And then range is the number found by doing the largest number minus the smallest. All right, so if you have numbers ranging from, a list of numbers that go from 1 to 10, your range is 10 minus 1, 9. All right. Then we have over in our box here, the idea of I. I is an imaginary number that stands for the square root of -1. And the most important thing about I is that if you square it, that means you end up with -1. Okay. And that is something they will definitely test. They may go further, but you just want to remember this. All right. Then let's do a little geometry. Geometry is going to be more important on the ACT than the SAT, but don't want to get caught out on remembering these names. So an isosceles triangle is a triangle that has two sides the same and one side is different. And remember that the sides and the angles are related. All right, so the angle that is across from the side is in some way related to it. So if these two sides are the same, that means these two angles are also the same. Then we have a scalene triangle. Scalene just means that everything is different. 1, 2, 3. All right, and notice these hatch marks I'm doing here. This is something I always do on the test to make sure that I am clear about what's going on. And then last, we have our equilateral triangle. Sounds like equal, and that's what it means, is all the sides are equal and all the angles are equal. And remember, triangles add up to 180 degrees. So that means that for the angles that are all the same, 18 divided by 3 is 6. So 180 divided by 3 is 60 degrees. Okay. Next, we're going to talk about some linear equations. First one, y equals mx plus b. This is going to be super important, especially on the SAT. This is how you describe a line. M is the slope, and b is the y-intercept. All right, so if they're ever asking you about any qualities of a line, you just go ahead and put it into this format so you can use it. Now, remember that slope is the way that the direction the line goes, and it's going to be represented if it's usually as a fraction as rise over run. All right, so you can find slope by using this formula, y2 minus y1 over x2 minus x1. And this is just to make sure you don't mix up your formulas. So if you have like 2, 3 and 1, 5, if you're going to do your y's as 5 minus 3, you need to make sure that you do your x's as 1 minus 2. All right, because mixing them up will get you the wrong slope. And one last thing about this in this moment is I just want to make sure that we remember that when a line goes in that direction, that is a negative slope. All right, if it tilts up, then like from left to right, it goes up, that is a positive slope. Sometimes all you need to do is recognize what kind of slope you've got. You don't even have to do the math. So always check for that. Next, parallel and perpendicular. So this is more about slope. So when we have two lines that are parallel, that means they do not touch, and that means they have the same slope. So if the question says something about two lines being parallel, and they give you an equation, odds are the fact that they have the same slope is going to be an important concept. Then perpendicular lines form a 90-degree angle, and the slopes are the opposite reciprocal of each other. So I'm going to write that down, but you won't need to know the words. You will just need to know what it means. So this is opposite reciprocal. Oop, there's an L there. And that will mean that if one has a slope of 2, then the opposite is going to make it negative, and reciprocal is going to mean you flip it. So it becomes 1/2. All right. Then the y-intercept. So the y-intercept is just where the graph touches where the line touches the y-axis. So that's going to be right here on the line I drew earlier. And the biggest concept with that is that that means x equals 0. A lot of times they give you an equation and they say at the y-intercept, what is the value of y? And if you just plug in 0 where the x's are, then it's an easy question. All right, same deal for x-intercept. You just make y equal to 0. All right, then we have directly proportional and indirectly proportional. So direct, and they're not really going to do a lot of math here. It's just a concept, the idea that as one thing goes up, the other goes up. That's directly proportional, whereas indirectly proportional means that as one goes up, the other goes down. They have an opposite relationship. Another word that they will use instead of indirect is inversely proportional. Okay, all right, and we have gotten through page 1. All right, let's keep rolling. Let's look at page 2. All right, so more geometry. Like I said, that's going to be for the ACT. And we want to just brief review. So for the SAT, SAT students, you will have that little formula cheat sheet at the beginning of your math section. ACT students do not get that. All right. Most of the SAT formulas are geometry. All right. So just you can double check on me with these. So area, if we're talking about a rectangle, area is base times height. And if we're talking about a triangle, area is 1/2 base times height. Perimeter is the sum of the lengths of the sides. So it's just the fence around the garden is how I think about it. All right, let me spare you my handwriting and say sum of the lengths of the sides. All right, then we hit volume. Volume is moving into the 3-dimensional shape. So volume is going to look like this. And that's the one that is length times width times height. All right. What they may give you on the formula sheet, they will give the SAT, they'll give you this, but they will not give you the formula for any other shape that is a cylinder or I don't know how to express it, a prism. Yeah, that's how you express it. So the trick with finding the volume of any shape like this, where it's the same shape all the way down, it doesn't get smaller, is you're going to find the area of the top, the face, and then multiply it by the height. All right. So the area of a circle is pi r squared. So the volume is going to be pi r squared h. All right. Area of a triangle is 1/2 base times height. So volume is going to be 1/2 base times height times the other height, right? So there's this height and there is this height. All right, then we hit surface area. So surface area is the, let me get my text again. It is the sum of the area of each side. All right, so you're going to just find the area of every single side of the shape and then add them all together. When I think about this, so I think about a fish tank. Volume is the water in the fish tank, and surface area is the glass around it, if a fish tank had a glass top as well, right? All right, next we have area of a circle. I've already given that away, but I'm going to say it again. Area of a circle is pi r squared. And notice when I'm writing this, I always, so like with this one, I didn't do that. I always write the whole formula, area equals whatever. And that is a method to avoid some errors in the math section. Always write more than you think you need to, and write the formula, then fill it in. It just helps your brain to not suddenly decide to put diameter, for example. All right. So we have area of a circle, and then circumference is 2 pi r. All right. And you can see I've got these ordered a certain way because these are the ways that these are things students mix up. Area of a circle and circumference, super easy to mix up, right? Because they're very similar. So find a way to remember it. And if you have like a trick, I would love to hear about it in the comments because I'm still looking. And then volume and surface area, area and perimeter. These are things students mix up all the time just because we're not at our best when we're taking the test, right? So you just want to be extra careful that you are thinking of the right concept when you see these words. All right, now we're moving on to some words about circles. My goal here is just that if they should use one of these words in a question, it's not the first time you've seen it in a while. All right, so we get our circle, and then an arc is a part of the circumference. Okay. A chord is any line that goes through the circle. All right. And the longest chord is going to be the one that goes through the center, otherwise known as the diameter. There's the center. And then I'm going to go ahead and draw a radius as well that goes from the center to one side of the circle. Often when if they draw the shape for you, then they are not going to draw the radius where you need it. So remember to think creatively about where that radius could go. Like, for example, you see how I just drew 2 radii and now I have a triangle to think about. So you never know. All right, and those are all the circle words. So then let's move on to scatter plot and line of best fit. So a scatter plot is one of these where you've got data points that do not fall on a line. All right, but they do have a general trend. And then the line of best fit is going to describe that trend as best it can. All right, it'll give you a general idea of is this a positive slope, a positive trend, that kind of thing. There's a couple different ways that each test will test this concept. One way that I've seen that they haven't done recently, but you never know, is they'll say, you know, when x equals 2, then what is, according to the line of best fit, what is the value of y? And students will get it wrong because they will look at the dot instead of the line, which is what the question asked for. So you want to be very careful when you're taking the test that you are doing what they ask you to do. All right. The other way that they've been testing this more recently has been by saying, you know, that this represents the number of shirts sold and every day. And the line of best fit represents the prediction of the number of shirts sold. So then they'll say, how many times did the prediction predict more shirts would be sold than were actually sold? So then you are looking below because you're looking when the prediction was higher than the real value. And so then you would count your dots, 1, 2, 3, 4. All right. And you just want to be really clear about, are you looking above or below the line? Because that's why students get that question wrong. They just they go for the wrong side for whatever reason. All right. All right, then an undefined fraction. An undefined fraction is any fraction that has 0 in the denominator. All right. So they may ask you to solve for the denominator, and all they'll tell you is that it's undefined. So you just need to remember that means that there is a 0 down there. All right, then we hit absolute value. That's that thing with the bars. So absolute value can be -2, and then that just makes it positive because it is the distance of the number from 0 on the number line, and distance can never be negative. All right, we'll talk more about that in a minute. Then we have on our XY graph, range is Y, domain is X. All right, so if they use those words, you just know which axis they're talking about. All right, let's move on to the next page. We have our absolute value in equations. So first of all, if it's just straight numbers, then you just, work through it. 3 minus 2 is 1. We're not changing signs or anything. It's just whatever value you end up with in there will end up being positive if you take the absolute value. If it's already positive, then your work is done. And then we do 1 minus 8. So the answer will be -7. And that is the correct answer. All right. So just because you have absolute values does not mean that negatives aren't in this universe. All right. Then we have a variable. So when you are solving for a variable, you've got two options. You got two ways this could have gone. All right. So yes, x minus 2 could be equal to 4, but x minus 2 could also be equal to -4. Right? And then it got absolute valued. So we want to look at, and then we can just solve it. So we'll say x equals 6 and x equals -2. All right. Okay. All right. Let's go over to our exponent rules. So these are the things that they test all the time. So go ahead and copy these down with me, and then we will talk about what they mean. All right, ready? So when we have exponents separated by a parenthesis, we are just going to multiply them. So this will end up being x to the 6th. When we are multiplying two together, we will add their exponents. So plain x has an implied 1 right there. So that's going to be 2 plus 1 is 3. All right. When you are adding, this is my trick one, you cannot combine them. All right. That's why we get quadratics like x squared plus 2x plus 6 or whatever. But what we can do is talk about factoring here. So remember, you can pull an x out of there, and then what would go in the parenthesis? X right here, and then plus 1, right? We need that plus 1 as basically a placeholder for the other x. Then when we are dividing, we will subtract the exponents. So this will just be x to the 1st, or just plain x, because 3 minus 2 is 1. Anything to the 0 power is equal to 1. Anything to the 0 power is equal to 1. All right, that's an important one to remember. Then if we have a negative in the exponent, that is going to be about the reciprocal again. So instead of x to the -2, it's going to be 1 over x squared. Once you have flipped it into the other part of the fraction, then you can lose the negative sign. All right. And then one more, when you have a fraction in the exponent, what that means is the numerator is going to stay, but the denominator will go into the radical. All right. And you will want to be comfortable with both ways of doing this, to go from the radical to a fraction and from a fraction to radical. All right. And there are some great worksheets out there to to practice this. Proportions are about creating a relationship, a ratio, and you just create those fractions and make them relate to each other. The trick is consistency. You want to make sure that what you're putting on the top of one fraction, you put on the top of the other. So let's go over here to this part. This is actually proportions. And so we could talk about part to whole. All right. And so if we know that these two triangles are related, for example, we could say the relationship of BA to AC is the same as ED to DF. All right. And I would write that as BA to AC. And notice I'm being real careful. I know they should be in alphabetical order, but I'm not going to worry about it. I'm doing the like upright part and then the base. So again, upright part and then the base. All right. And then that way, if I know everything except for perhaps the length of DF, then they would be able to tell me, I would be able to figure that out, because now I've got it in a proportion. I can just cross multiply my values. All right. Makes things really easy sometimes. Same for if, there are 3 kids out of 10 have gone to Disney World. All right. So if that's true, if there are 250 kids, how many have probably gone to Disney World if the proportion is the same? You see, and I can just cross multiply and get my answer. So makes things really simple and easy way to set it up. Then we hit probability. Probability is the same. It is also expressed as a fraction. And you just always want to express it as what you want over all of your options. Okay. So if I say, what are the odds, what's the probability or the odds of picking a blue circle out of all the shapes here? Well, there are 2 blue circles. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 shapes. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just want to make sure. And then if we have, and you can simplify that down, you should simplify that down to 1/5. But the SAT particularly likes to limit your options. All right. So if they say, if you choose a circle, what are the odds that circle will be blue? All right. So now still want 2 blue circles, but they said if you pick a circle. So our options are only circles. So that's 1, 2, 3, 4, 5, 6, 7. 7. You see how the probability changed because they limited us? All right, so just keep an extra close eye on that. All right, moving right along. Next thing are some very commonly made errors. All right, so let's see what we do here. So x plus 2 squared. Squaring just means that you multiply by itself, right? How do you think students get this wrong? They tell me it's x squared plus 4. All right, you see how that's not enough. So you cannot just distribute the square. All right, but you can distribute just a plain number. So you're going to get 4x plus 8 here. All right, and then this next one, this one's interesting to me because I was going for one kind of error, but I actually got 2 kinds of errors that students do. First, some students will try to do 10 minus 4 first. Why can't you do that? Remember PEMDAS? Got to do your order of operations, and parentheses come first. So we need to deal with that first. All right. And so that means our 10 stays, and we'll get minus 4x and then minus 8. How do you think students get this wrong a different way? It's this 8. They always end up with plus 8 because they forget the minus, right? So be so careful with your minus signs because it is so easy to lose them. And obviously that's going to ruin your question. So Should be super, super careful. Next, we have solving using elimination. So this is the idea of solving for a variable when you have two equations, and you can isolate a variable and then plug it in. That's a legitimate way to do it, but a lot of times it's more complicated, and sometimes recognizing what's going on will make the question quick and easy. And of course, quick is always a good thing on the test. So you can combine the two equations, and I'm going to, you can choose to add them, all right, because negative y plus y is going to cancel out. So I would choose to add these two together. X plus 2x is 3x. Negative y plus y cancels out. My equal sign comes down 2, and then 11 plus 19 is 30. So you see how quick that was in removing that y? It's awesome. All right. And then obviously I could solve for x, or perhaps they just ask me what 3x was. SAT loves that. So I'm done. All right. Now, sometimes adding doesn't work. So you can also choose to subtract. All right. Some of my students choose to multiply everything by -1 and add, so they can still add, but then everything's negative. If that makes more sense to you, feel free. I feel like that takes more time, but absolutely do what you're comfortable with. So 8 minus -3, subtracting a negative is the same as adding a positive. So we get 11x, y minus y cancels out, and -16 minus -5 equals -11. So once again, quick, easy solve. All right. And if the numbers don't work where you can't just immediately add or subtract and cancel something out, you can choose to multiply one of the equations by something to make it work. So like if I wanted my x's to disappear on the first one, I could multiply this whole first equation by 2 and end up with 2x minus 2y equals 22. And then get my 2x plus y equals 19 from the other equation. And now I'm going to subtract. So those guys disappear. -2y minus y, so -3y equals 22 minus 19 is 3. And so now I've solved for y instead. All right, cool. All right. And then we have some formulas that you will not get, regardless of if you're an SAT or an ACT student, but they will test you on these. First, the equation of a circle. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. All right, so r is going to be the radius, and h comma k is the center of the circle. Notice it's minus h minus k, but it's going to be just hk as the center. So we would be able to look at this equation and then, eyeball this circle. Normally, if they're going to do this to you on a question, they'll mark everything, of course, but I can know that this is r. So let's say, this is 1, 2, 1, 2. So that means my radius is 2, and my center is going to be, what is that? -1 comma 0, right? Because I went over on the x, but not up on the y. And then my radius is 2. So that means that the formula would be written as x plus 1 plus, all right, and I can write y minus 0, or I could just write y equals what? 4, right? All right, so and let me just go ahead and write it the other way. So x plus 1 squared plus y squared equals 4. Okay. And what they'll probably do is either show you the equation and ask you to match it to a circle, or they'll show you a circle and ask you to match it to an equation. All right. Sometimes they'll want you to manipulate the equation so that you can talk about the circle. And that's that's another concept for sure. All right, then we have our circle, then the ellipse. So that's this oval. And the formula for an ellipse is very similar to a circle. So we have x minus h squared over rx squared plus y minus k squared over r y squared equals 1. All right, ellipses will always equal 1, and it's the same deal. H comma k is the center. All right, but this time you've got these r's, and so this is usually written as a and b, but I prefer to talk about it like this: r sub x, r sub y, just because r, you're already familiar with that. That's a radius, and it's just different for the x-axis versus the y-axis because it's an oval. All right, so rx is going to be along the x-axis, and ry is going to be along the y-axis. So you would just find those distances, plug them into the formula, square it. All right. And this will be later in the test because they don't expect you to know your ellipse formula. And it'll just be look at the picture and match it to the equation. Okay. All right, then we have a few more things. We have our quadratic formula. Quadratic formula is that formula you may have a song for: negative b plus or minus square root of b squared minus 4ac over 2a. And this is for solving for x when factoring is not easy. So you'll have a quadratic formula in ax squared plus bx plus c equals 0 form. And you can take your a, b, and c and plug them into this formula to figure out what x is. All right. Then let's see, we also have matrices. Matrices are the idea of your data being in a little box like this. All right. And the trick here is, so if it's adding or subtracting, it's all about location. So you just say, okay, 1 plus 7 is 8, 2 plus 8 is 10, 3 plus 2 is 5, and 4 plus 1 is 5, and that's your answer. That's it. All right. Things get messier if they ask you to multiply. So I'm going to change this up. And this is when you would want to get your calculator out. All right. So your calculator has a matrix button on it. If you do second matrix, do you see that button there? And then what that'll do is get you into your matrix screen. You can right click over to edit and then have your matrix with all the numbers in it. And then when you've put the numbers in that reflect what your question says, you quit, go back to second matrix, and just press enter. And then you can pull the matrices out into the main screen. So it'll look something like this. This isn't going to match my numbers, but you see how that went ahead and gave me a matrix answer. It's the easiest thing to do. So I would, so just, be comfortable with using the matrix button on your calculator. And the other important thing about a matrix is to make sure, so they'll always express it as row and then column, a row by column, basically. The rows go across and the columns go down. So this isn't a great example because you've got a row of 2 and columns of, there are 2 columns as well. So if we instead did something like this, 1, 2, we would, sorry, that's 3. That's 2 rows and 3 columns. All right. And then the rule for matrices when you're doing a certain kind of math is that with the matrices, when you are multiplying them together, you need the columns of the first one to match the rows, the number of columns to match the number of rows in the second one. All right. Now I've messed up my triangle over here, so go ahead and take what you need, and then I'm going to subtract math mode. I'm going to erase. There we go. All right. So then SOHCAHTOA, this is the trig that they talk about. They say that they test trig. Well, I'm going to say 9 times out of 10, it's going to be SOHCAHTOA they're testing. So got to have that 90-degree angle. You can only use SOHCAHTOA on a right triangle. And this is the idea that sine of theta equals the opposite over the hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. All right. And remember, with a right triangle, the hypotenuse is always going to be across from the 90-degree angle. The only trick with this is that it matters what angle you're using. If you're using this angle, then this is the adjacent side and this is the opposite side. If you are using this angle, then they switch, right? This is the adjacent and this is the opposite now. So you just want to be real careful with how you label your triangle, and then follow and do what they ask you to do. Go back to soothing pink. All right, so vectors. Vectors are the concept of force. So you would you'd recognize that force is going in a certain direction and the length of the line tells you how much force there is. All right, so if we have two vectors going in this direction, the composite is going to be right down the middle and a little bit stronger than either line on its own. All right. However, what we can do is also recognize that if we have, let's say, one force going this direction, the other force going this direction, well, then we need to worry about it's going to limit the composite force. So it's going to be less than either line because they're kind of working against each other, but the direction will still be pretty much halfway between. All right. The other way that they test vectors is in the complex plane. They'll express it as a plus bi, and this is just another way of writing a point on a graph. And so when they'll say, 2 plus 7i and 5 plus 2i. And then they'll ask you the question I'm thinking of, they ask you to find the midpoint. All right. The way to read this is just that the A location is your X and the B location is your Y. So it's 2, 7 and 5, 2. All right. So once you've made that change, then you're back to a comfortable coordinate graph. All right, then for the SAT, we're going to talk about stem and leaf for a second. Haven't seen this in a while, but you never know when it's coming back. So let's talk about it for a second. So the stem and leaf is a way of displaying data where they might list a bunch of numbers. All right, and they're going to tell you line 1 equals 11. And then the questions I've seen, they ask you, to find the average of the numbers, for example, or maybe the median. All right, what you need to do is recognize the pattern. So they've told us that the left-hand side is the, not the ones. They've told us that the left-hand side is the tens and the right-hand side is the ones. And so we have 11. Oh, and I did this wrong, didn't I? So that 0 should have been first. All right, well, let's ignore it. So we have 11, 10, embarrassing. That won't happen on the test. 22, 27, 28, and then 31, 31, 31. That's the list of numbers. And then you would do whatever you needed to do, find the average, the median, whatever. All right. Then the box and whisker is its own little monster. So let's make this bigger so I've got a little more room to write on. I'm going to also erase this so it's not in my way. Box and whisker is another way of displaying data that is all about medians. All right, let's go ahead and put that off to the side in capital letters. It is about medians. Remember, the median is the middle number when all the numbers are in order. So the box and whisker will look like this. You'll have a number line and then a box and whiskers. And actually, they've been calling it a box chart recently. So it may not be called a box and whisker exactly. But it'll look like this. And the way to read it is that middle line is going to be the median of all of the data. All right, so the exact middle number. All right, these two sides of the box are going to be medians of half of the data. All right, so if I have numbers, let's say 1, 2, 3, let's just go for this, 4, 5. There we go. My overall median would be 4, so that would be this middle line. The medians of the sides of the box are going to be this half and this half. So it's going to be 2 and 6 here and here. And then the whiskers, the farthest lines are going to be the first and last number. So smallest number and largest. All right, and those are going to be the actual values of the graph, so, or the list, so 1 and 7. All right. Generally, what they've done is they will show you a box and whisker or box chart, whatever they call it, and then they will ask you, what is the median of the data? And you just look for the middle line, and that's it. That has been the last few tests I've seen as of March 2022, but you never know when they might, decide to make it a little more complicated and do the sides. All right, very last thing is this. So go ahead and do a screenshot of whichever of these is relevant to you. We've got our ACT math questions and our SAT math questions. This is put together by my friend Mike McGibbon of Math Chops, a really amazing math program that I strongly recommend. You can look up mathchops.com online, and it's a great program for practicing test-specific math, SAT or ACT, and he is also broadening that to other tests as well. So if we look, I'm going to go ahead and zoom way out so that we can compare the two. You can see that the tests, they both test math, but there's a little bit of a difference in the focus. With the SAT, there is a ton of y equals mx plus b. All right, ACT, it's not so much. With the SAT, they love some proportions, as does the ACT. And then, but if we look at the ACT, we can see that pre-algebra is a big moment for them. Also area, perimeter, volume, that geometry I was talking about. All right. So if you are trying to increase your score and wondering where your specific weakness is, I would make this a jumping off point to look and see if there's anything here you want to review. And then and then take a practice test. That's the easiest way to know. Take a practice test, see what you miss, and see where you can improve. So that is it. That is all of the math I want to talk about right now for the SAT and ACT. And I want to thank you for riding along with me and filling this out. If you have any questions, feel free to either leave me a comment or you can email me at testprep@flamingotutoring.com. And I'll look forward to hearing from you. Have a great day.